Okay, let's talk about domains and continue with what we introduced with them before. Now, if you take a look at the example that I have written where it has x less than or equal to a negative 2, and if we're going to graph this using the domain, or in other words, using the real numbers. Now remember we talked about the difference between graphing real numbers and graphing integers. When we graph real numbers, we use a solid line with an arrow going one way or the other. Now if we're graphing integers, we just use dots. Now the reason that, or the difference between these, is because when we use the solid line, that's representing decimals, fractions, every number you can think of. But when we use dots, that's representing integers, which are not fractions or decimals. So in the first one, if we're going to graph x less than or equal to a negative 2, if we're going to show numbers less than or equal to a negative 2 that are real numbers, if we're using real numbers. So since we have the equal sign underneath the less than, we're going to have a solid circle, a filled in circle, and then represent numbers less than a negative 2. I would shade everything to the left. And we're using that solid line that I talked about up above because we're using real numbers, and real numbers are fractions, decimals, every number you can think of. Now the same type of example that I have in the blue, except this time we're only going to use integers. So in other words, when we say numbers less than or equal to a negative 2, we're going to use integers that are less than or equal to a negative 2. We're going to show or graph integers less than or equal to a negative 2. That is what they're specifying by the domain. So now since it's less than or equal to a negative 2, the first integer would be a negative 2. Because certainly if I put a negative 2 in for x here, is a negative 2 less than or equal to a negative 2? Yes, it is. Now what's the next integer less than or equal to a negative 2? Well, it'll be a negative 3, and then a negative 4, negative 5, negative 6, negative 7, and the arrow at the end here means that this pattern continues. So there's a couple things here you want to remember from what we've talked about before, is the difference between using the real numbers to graph and using the integers to graph. All right, the new part, or the continuation of domains, is example 1. And notice the example. We have x plus 2 is less than 5. And the numbers we're going to use for graphing are going to be the integers, so dots. Now the first thing you'll notice is this problem is a little different. First of all, I got to isolate or solve this for x. And it would be the same thing. When I solve this for x, I'm going to treat this exactly the same thing as if I had x plus 2 equals 5. And when we solve this equation for x, let's see, they're adding 2, we'd subtract 2. And we'd get our answer. Now you do the same thing even if you have this inequality. Let's see, they're adding 2, so we're going to subtract 2. They cancel. So x is less than, let's see, 5 minus 2 is 3. So now it's like the problems that we've done before. So I'm going to graph numbers less than 3 using integers. Numbers less than 3. So in other words, would I have a dot on 3? Is 3 less than 3? No, it's not. But I'd have a dot on 2 because 2 is less than 3, on 1, on 0, and this pattern continues even though at the end I don't have any other numbers, but the arrow means that they do keep on going. Now what would be the difference in this example if we were going to use the real numbers? So in other words, numbers less than 3, that would be the real numbers. So in this case, let's see, real numbers less than 3, I'd have an open circle on 3 because 3 is still not included, but then I'd shade it. I'd use that solid arrow going to the left. All right, final example that we have is, now we're going to graph x minus 5 not less than 0. Now the first thing I need to do is replace the negated inequality with what it means as an inequality. So let's see, this means the same thing as x minus 5. Not less than means the same thing as greater than or equal to 0. Now I solve it. Let's see, they're subtracting 5, so I'm going to add 5 to both sides. So the 5's cancel, and I get x is greater than or equal to 5, because 0 plus 5 is 5. Now, I'm going to show numbers greater than or equal to 5 using real numbers. So a solid line. So let's see, greater than or equal to 5. That would be a closed circle. Now remember, also something to keep in mind, a closed circle versus a open circle, really when you use the differences with those, you're dealing with the real numbers. So now let's see, greater than or equal to 5 using real numbers, then I would use a solid line and shade it to the right. And this shows the difference between the equations or the inequalities that we used with the domains part 1. The difference here is just that you're solving the inequality, then you're graphing it using the real numbers or the integers.